A discussion about node modules is incomplete without talking about callbacks and error handling. What are callbacks and why are they essential for supporting asynchronous computation that is very useful when we write Node.js applications? How is error handling done in Node applications? Let's talk briefly about these in this lecture. Before we proceed on to talk about node modules and callbacks, we need to understand two salient features about the JavaScript language itself. First and foremost, JavaScript supports what is called as first-class functions. What we mean by first-class functions is that a function can be treated just like any other variable, and hence functions can be passed around as parameters inside function calls to other functions. And that essentially allows us to send in functions as callback functions that can be called from another node module in order to get some work accomplished. We'll look at how this is very useful in supporting callbacks in Node.js. The second aspect about JavaScript is the support for closures. What we mean by closures, especially if you are familiar with functional programming languages, you understand how closure works. A function defined inside another function automatically gets access to the variables that are declared in the outer function. So even if the outer function has completed execution, when the inner function executes later, the inner function will still have access to the values of the variables within the outer function. And this is again very effectively used when we use callbacks in Node applications. If you are used to the standard way of writing applications, then you are familiar with synchronous computation, where you specify your computation as a set of steps to be done one after another. Now, if you organize your computation as follows, as shown on the left side of this slide here, we have computation 1, then followed by computation, a long-running computation, followed by computation 2 and computation 3. So in this arrangement, let's assume that computation 2 is dependent upon the long-running computation completing its work. Then it makes sense for computation 2 to wait until the long-running computation is completed before it gets executed. Now, we might have another piece of work to be done, which is defined by computation 3. Computation 3 may be in no way dependent upon computation 2 or the long-running computation to complete before it is executed. So in this case, if we do synchronous execution of this computation, then computation 3 will get stuck even though it is no way dependent upon the completion of either computation 2 or the long-running computation. So whereby the amount of work to be done by computation 3 will be delayed because of no reason of its own, and instead is delayed because of something that precedes it in the sequence of computation. Now, in asynchronous computation, we can rearrange this work in such a way that computation 1, when it completes, can spawn off this long-running computation to be done behind the scenes independently. And since computation 2 is dependent upon the long-running computation to finish, then computation 2 can be executed when the long-running computation is finished. Now, this frees up computation 3 to continue on right after computation 1 finishes. So this way of arranging ensures that computation 3 will finish much faster than being stuck behind the long-running computation and computation 2. So this approach of rearranging your work is very useful, especially when you have long-running computation, that especially IO-bound computation to be done. So in this case, you can spawn off the IO-bound computation, and when that completes, then whatever needs to be done thereafter can be sent to it as a callback. So computation 2 will be turned into a callback and then given off to the long-running computation. So when that completes its work, then it'll call back the function that is enclosed inside the callback. So this is leveraged very effectively by Node.js in rearranging the computation within our Node applications. Now this is very, very useful when we look at the way Node.js itself runs. So as we realize, Node.js is organized into a single-threaded event loop. This single-threaded event loop basically picks up requests as they come in and execute it one after another. Whenever it needs to spawn off an IO request, the IO request will be spawned off, and any work that needs to be done after the IO request is completed will be enclosed inside a callback. So when the IO request completes, then it will put the callback into the request queue, and the callback will be handled thereafter by the event loop. So the event loop is a continuously running loop which basically picks up requests from the request queue and then services them one at a time. So when you think back about it, you realize that Node.js is a single-threaded, but at the same time it is able to achieve much faster rate of completion of work simply because of the judicious use of callbacks and the asynchronous execution of IO requests, like for file accesses or database or long-running processing that can be done independently behind the scenes. Now, the way the Node.js event loop handles all this is that the event loop is arranged in a sequence of phases. So as you see in the diagram shown here, the phases include timer handling, IO callback handling, then you have idle prepare, then the poll where the incoming requests for connections or data are handled, and then the check phase, and then finally the close callback phase. Now, some details about what is done in each of these phases is listed to the right side. In the timer phase, the event loop handles anything that is triggered by the set timeout function in JavaScript. The IO callbacks are executed. Almost all the callbacks that come back to be executed after an IO request will be handled with the IO callbacks queue. So each of these phases maintains its own separate queue, and the Node.js event loop picks up requests from each of these queues and handles them. The idle prepare is meant for internal use by Node.js. The poll is where it retrieves new IO events to be handled and perhaps requests coming in from outside. The close callback phase handles any socket closures that need to be handled and so on. Now, we don't need to worry too much about all these details if we need to really write a Node.js application. When required, we will look at some of these details as and when it is essential for understanding how our Node application works. But for the moment, this gives you a big picture view of how the Node.js event loop is handled. Suffice it to say that this is sufficient enough information for us to understand the Node applications and how they work for the moment. If you want to know more details, then I have given you a link to a detailed description in the Node.js documentation, which explains about the event loop in more detail. With this quick understanding of Node callbacks and error handling, we will move on to the exercise where we will look at how a Node application can be written with callbacks and how errors can be handled inside a Node application. We will see repeated use of this pattern in subsequent exercises and subsequent lessons, specifically when we look at Express and how we build server-side applications using Express in more detail in the later part of this course.